Okay, ladies and gentlemen, we are continuing our conference, and I'm glad to declare that now we're going to have the final part. And this final part will include 5 presentations. Let me show them. Okay, I hope that everyone already joined. And of course, I congratulate everyone that we got a new TRIZ master finally. So, but let us not to lose time because it's Saturday and Saturday evening is approaching. So you see on the screen the agenda for today. And let me find the presenters for the first presentation. And the first presentation is by Zhao, Aopling, and Dongshuang Hu. It's called a case study on enterprise product research and development based on customer demand. And who is going to present?
Hello, Valerie.
Yes.
I'm translator.
Okay, clearly. All right.
Zhao. Yeah.
Please move ahead. The floor is yours and the screen is yours too.
Okay, thank you.
You're welcome.
So can you see my screen?
Yeah, we can see a screen.
Okay. Hello, everyone and every TRIZ masters. And I'm sorry, I forgot to turn on my camera. Just wait a minute.
Okay.
Yeah. So I am translator of Zhao, and I'd like to introduce our papers to you all today. So I will talk about a case study of enterprise product R&D based on customer demand. So while promoting TRIZ and practice TRIZ in enterprises, we found that there are 2 questions enterprises pay attention to. The first is the new product R&D, and the second is the breakthroughs on core technologies. So in terms of the product R&D, we find that we should pay attention to customers' demand. We have to meet their demand. Otherwise, we will take us a long time to develop our product, and the cost will be higher, and we will get complaints from the customers. And there are many other questions. So we found that it is very necessary to set up a demand-based product R&D process sizes. So we have, in order to set up the process, we experienced about 3 stages. We were instructed and guided by Professor Sergey Ikovanko and many other TRIZ masters. So the 3 included exploration, establishment, and verification. In the exploration stage, firstly, we should understand the market demand. So we use the VOC and VOH, the demand, and change it into parameters. And we analyze the demand through KJ channel model and other analysis methods. And then we also use MPV analysis to transform the demand into functions. After understanding the demand, we consider design product function. So we define system and establish the function model, and we also use the fast analysis. And in the next stage, we started to evaluate the product solution. So we generate many different kinds of solutions, and we collect them and establish our evaluation model and rank these solutions. And then we can substantiate it and verify it, choose the best solutions for use. And then we can establish a complete demand-based product R&D process. So starting from demand domain, we can into function and into structure, and then we get the product that we want. So we need to pay attention that this process is a closed circle, which means it is virtuous. So after we get the right product, we can go back and see the demand domain to see if the customer's demand has been met in this product. I like to introduce a real case study. So we have applied the process to this project. So this case is about a Chinese company. The Chinese company produces a product which is the laser level. So the laser level is used for home decoration. It can emit vertical and horizontal lights, and we want to have something. If we want to accurately to precise to tackle some projects that require the utmost in precision, so we can use laser level. For instance, if we lay in tiles, install cabinets, or frame some picture at home. But there is a problem about this product. The company got complaints from customers. So conditions, when the laser level is tilted over 5 degrees, its alarm system will be triggered. So the laser level will beep and emit no light. So the problem is that when the laser level is tilted over its maximum self-balancing degree, it doesn't beep and it still emits light. So according to this problem, the company, the workers tried many ways to figure it out. For instance, they have tried to wipe the gasket and spring with alcohol, or they also tried to change the gasket and spring, but it doesn't eliminate the problem. So how to solve it based on our process? Firstly, according to the process, we need to confirm our demand. So we collect demand from our clients. There are many different complaints, such as they are not satisfied with their appearance design, or they think the alarm system is not good enough, the precision is not good enough. We also collect demand from work sites, like the laser light doesn't work or LED doesn't work. After collecting all the demands, we cluster them and we categorize them. We got the MSPB. You can see in the chart below. The MSPB includes energy consumption, light shape, portability, alarm reliability, measurement accuracy. And after we got the MSPB, we use MPV analysis and got the MFPB in this role, like control precision pendulum. So we have we analyze the relation between MSPB and MFPB, and we found that we analyzed their ranking, and we found that there is a most important problem that the engineers should be tackled. So which is the alarm reliability. So we need to solve the problem to improve the alarm system and improve its alarm reliability. And then we can start to design our product function. We set the system boundary, and in this picture, there are the components of the system of the laser level. And then we established the function model, as you can see on this figure. And we found 4 major function defects, including lack of leveling function, and there is not sufficient contact between the alarm and the gasket. So the alarm system cannot be triggered at time. And the third defect is that the information conducted to the PCB is not insufficient. So the PCB cannot stop emitting the lights. And the fourth defect is that we don't have measurement device to measure the tilt angle of the pendulum. Based on the function model, we can create a fast analysis, and we can consider how to realize the structure of this function. Based on the previous 4 function deflects, we came out 7 solutions, as you can see these pictures on this slide. So in order to improve its leveling function, we consider super system, and we introduce the leveling base. This is our first solution. And then the second one, in order to improve its conductivity, we can consider to place silver or gold on the gasket. We also consider to use contact control by using the reflective paper and photoelectric switch. So when the pendulum tilts over 5 degrees, the sheet will deviate the switch. So the switch cannot receive the signal reflected by the paper. So it will trigger the alarm system. And then we also think that we can add some red copper on the pendulum to increase its weight. We can also add some bumps on the gasket to increase its contact area. And as for the 6th plan, we introduce the pendulum sensor in the laser level to replace the gasket and the spring. So the tilt angle of the pendulum can be measured, and it also generates new function. We can measure the levelness of the laser level. As for the loss solution, we combine the gasket and the current into capacitor, and when the pendulum swings, the capacitance distribution will also change. So we can judge the tilt angle by the capacitance. So based on the previous analysis, we decompose the function and use morphological matrix. We got different functions and solutions combined. So there are a total of 96 combination solutions through the matrix. And then we started to select the available solutions and the innovative solutions. Finally, we got 7 solutions, and we also got some solutions that can be used to develop new products. But here in this project, we only focus on the solutions that can meet our So we established the evaluation model, and we rank these 7 solutions. So we can see in this chart, the third plan got the highest. So we thought the third plan is the best solution here. So we started to test and substantiate the third plan. We produced 30 prototypes and tested them. According to the results, the alarm system worked very well. So there is no alarm function problem. As for the 6th and the 7th plan, these 2 plans are advanced, but it takes very long time to develop. So we consider maybe in the we can use these 2 plans to develop some new products. And we also find that there is no related patent that has been applied. So we think it is patentable, and we are applying the patents now. Through the project, we invested 4,400 yuan in this project, and until the reporting day, we estimate that we can get total revenue about 22,000 yuan. The revenue is not very large. That project, we have built up our confidence on the demand-based product R&D process. And so through the real project, through the real case, it has proved our feasibility, the feasibility of the process, but it still needs to be constantly improved and developed according to different demand and real reality of different enterprises. We should process and make it more fitable and generate more outcomes for enterprises. So that is all about my thesis. Thank you for listening.
All right. Thank you very much. Now the question is, well, if there are any questions from the audience, please. We have 33 participants at this moment. Anyone? Maybe someone is typing a question where we can wait for a little bit. I understand this is the final day and people already a little bit tired.
Yeah, and the author Zhao is here. He will answer the question if there is any. And I will help him to translate.
Yeah, I'm sure that the questions could be. And well, there is a way to connect, and someone could definitely contact you after the conference, because this is a very important topic, because we have different ways to explore customer demands today. And by the way, did you approach the very powerful, the very popular, I would say today, approach to design thinking for identifying customer demands?
Is there a question?
Yeah, it's from me.
赵老师您在吗？
在。
就是那个Valerie 问您，就是有没有考虑过使用现在很受欢迎的这个设计思维还是什么 design thinking 这个
设计思维是吗？
对。
可以考虑，就是这个呢还是受到了那个 Sergey 他的那个 MPV 的那个思想的那个影响还是想 前期把需求这件事儿呢，把它分析清楚，这样呢，对于产品后期的这个研发会起到非常重要的帮助。设计思维呢，它也有很多好的这样的一些理念，也希望将来以后能够把它融入到这个流程里边去。毕竟呢，这个流程呢也是在不断的在完善、持续改进的这样的一个过程。本着两个方向，一个呢就是流程在持续改进，另外一个呢，要能把这件事儿能够很好的传递给那个企业的工程师，让他们能够接受，能够应用，这个是最重要的，而且要考虑跟企业的研发流程去进行结合。
Yes, we can consider design thinking, and for this current process, we got the inspiration, or we got the instruction from the Professor Sergei Kovenko's MPV analysis. So we think at the beginning we should correctly analyze the demand. It can help us to do the product research and the development at the later parts. And yes, design thinking, it has a lot of good ideas, and we can consider to integrate it into the process, because this process is also continue to improving and developing. So we hope that through the process we can help the engineers in the company to apply the process to their, and we should also consider the application and the R&D approach utilized in the enterprises.
Okay, thank you very much. I see no more questions coming. So thank you very much for your presentation, and thank you very much for your participation. Thank you.